This is question 2A from NCEA Scholarship 2016 Calculus. All right. So this is an integral. Sine fifth x plus cos of the fifth x. So we can split this into two different integrals. One is this. The other one will be this one. So sine to the fifth x is an odd function, and because the two limits here, they are same, but in different signs. So when we integrate an odd function like this, and the limits are same but have different signs, the integration will just equal to 0. Okay. So now what we have is this term here. So what we're trying to do here is because when we differentiate a cos function or sine function, we always have to. No, actually, when we differentiate any sine function or like this, like the power is more than 1, we always end up having a sine or cos, because if I differentiate this, it's going to be 2 sine x cos x, right? Because of chain rule, this will be minus 2 cos x sine x, which means if we were to integrate cos to the fifth x, it's not going to work, because we always need a sine x or a cos x to differentiate. We always need a sine x to differentiate the cos x, or cos x to differentiate the sine x. So, can we get a sine x here from cos the fifth? No, we cannot. So what we're going to do is we can make things mainly in sine x, and we're going to have one cos x, so we can differentiate the sine, right? So what we're going to do is this: cos squared x times cos squared x times cos x. Yep, that's still cos to the fifth x, but we're just going to split this up. So cos squared x, sine squared x plus cos squared x, sine squared x plus cos squared x equals to 1. So I can just rewrite this as this, then another one, cos x. So what we can do here is we can do a u substitution. So if I say, wait, hold on, before that, I'm just going to do this. 1 minus 2 sine, cos x dx. So what I'm going to do here is I'm going to do u substitution. So if I say u equals to sine x in this case, and so du equal to cos x dx, correct? So, and du cos x dx equals this. So which means this thing is going to equal to 1 minus 2. Remember, I'll substitute sine x by u, so this will be 2 squared plus u to the fourth du. Alright? So what we got here is, we just going to differentiate this straight away. So we got is 1, so that'll be sin x, 2u squared, which is, well, actually before that we should just write it in u's. So u minus 2 u to the third over 3, yeah, that's the integration rules, plus u to the fifth over 5. Yep, and that equals to sin x minus 2 sine cubed x over 3 plus sine to the fifth x over 5. And we're going to evaluate this. So what we're going to do here is do this sine pi over 2 minus 2 sine cubed pi over 2 plus sine fifth pi over 2 over 5. And this, then subtract this. Now we're going to subtract minus sine right. So now what do we do here? Sine pi over 2 is 1, so there'll be 1 minus so sine pi over 2, sine 2 sine cubed pi over 2. Hold on, let me just use my calculator. Is also 1, so this is just, yeah, that's just this, and minus pi over 2 is just sine minus pi over 2 is just minus 1, minus, actually this is plus, and this will be minus. We've got 15, actually that's 15 minus 15 plus minus another plus 5, 3, 8, 23. So we got 16 over 15. Nope. That's the question 2B, no, question 2A, right. Done.